What if the first signs of life outside Earth have already been found, not in movies, not in science fiction, but on a distant planet, far, far beyond our solar system? A place with a strange name, K218b, and what scientists noticed there made people all over the world stop and ask one simple, powerful question. Are we really alone in the universe? This isn't a story about little green men or flying saucers. It's a real scientific detective story, one that could change how we see everything. So, what exactly did they find, and why is it causing such a stir? Let's dive in. K218b is not a planet like Earth. It's bigger, much bigger. What astronomers call a sub-Neptune or a Hycean world, a planet with a hydrogen-rich atmosphere and a water-ocean surface. It's also incredibly far away, orbiting a dim red dwarf star about 120 light-years from us. To put that into perspective, if you traveled at the speed of light, it would still take you 120 years to get there. For a long time, K218b was just another name on a massive list of thousands of exoplanets discovered by telescopes like Kepler. It was just a data point, a dot in the cosmic ocean, nothing special. But then, scientists pointed the most powerful space telescope ever built, the James Webb Space Telescope, in its direction. And what they found, hidden deep within the planet's thick atmosphere, was something completely unexpected. Something that made the entire scientific community sit up and take notice. When the light from K218b star passed through the planet's atmosphere, the James Webb Telescope was able to analyze its chemical makeup. Think of it like a cosmic fingerprint. And in that fingerprint, they found traces of carbon-bearing molecules, including methane and carbon dioxide. Now, that's interesting, but not necessarily a sign of life. Many non-biological processes can create those gases. But then they found something else. A faint, tentative signal of a molecule called dimethyl sulfide, or DM. Here on Earth, DMs is almost exclusively produced by life, specifically by phytoplankton in our oceans. Finding it on a distant, water-covered world is a very big deal. It's what scientists call a biosignature. It doesn't mean we've found aliens. It doesn't mean there are cities or complex creatures swimming in its oceans. But it's a tantalizing clue. A chemical whisper across the vastness of space that hints at the possibility of biological processes. Why would a gas so closely linked to life on our planet be present on a world so incredibly far away? The news spread like wildfire. Headlines screamed signs of life found on alien planet. Social media exploded with speculation, excitement, and, of course, a healthy dose of skepticism. The reason this discovery captured so much attention wasn't because it was definitive proof. It's because it opened a door that, for many, had always felt locked. The idea that life might not be a unique miracle confined to our little blue dot suddenly felt more plausible than ever before. For centuries, we've looked at the stars and wondered. This discovery turned that wonder into a tangible, scientific investigation. It's the difference between saying what if and saying what if. We just found a clue. That small possibility, that tiny hint, is enough to fundamentally change our perspective on the universe and our place within it. It makes the cosmos feel a little less empty, a little less silent. Of course, in science, extraordinary claims require extraordinary evidence, and this is far from a closed case. There is another, very real possibility. What if these signals have a different explanation? What if there is some unknown geological or chemical process on a Hycean planet like K218b that can produce dimethyl sulfide without any life at all? Nature is full of surprises. We've only just begun to understand the complex chemistry of worlds so different from our own. Some scientists are rightfully cautious, pointing out that the DM signal was weak and needs more confirmation. Maybe it was a fluke, a misreading of the data, or a chemical process we haven't even imagined yet. This is a crucial part of the scientific method. A discovery starts not with an answer, but with a puzzle. And right now, K218b is one of the most exciting puzzles in all of science. The debate and the search for more data are just as important as the initial finding. So, let's play this out. What does this mean for us, right here, right now? Let's imagine for a moment that follow-up observations confirm it. There is simple microbial life churning away in the oceans of K218b. The implications would be profound. Earth would no longer be the sole cradle of life in the universe. It would mean that if life can start in two separate places, it can likely start in millions, or even billions, of others. The universe would suddenly feel teeming with potential, more alive and more mysterious than we ever imagined. But what if the opposite is true? What if further study proves that the DM signal was a false alarm, a result of some non-living process? That discovery is just as important. It would underscore just how incredibly rare and precious the conditions for life are. It would make our own planet seem even more special, a fragile oasis in an overwhelmingly sterile cosmos. Either way, our perspective shifts. We either become part of a grand cosmic biology, or we become an even more profound exception. The story of K218b is a perfect example of where we are in our search for answers. This is just one planet, a single grain of sand on an infinite cosmic beach. The Milky Way galaxy alone is estimated to have billions of planets, and there are billions of galaxies out there. Some are closer, some are farther. Some are fiery gas giants, others are frozen rocks, and some might be just right. Each new discovery, each new piece of data from telescopes like James Webb brings us a tiny step closer to understanding the bigger picture. We're moving from an era of pure speculation into an era of real, data-driven exploration. We're not just asking questions anymore. We're building the tools to find the answers. The universe is full of questions, and for the first time in human history, we are beginning to read the clues. So, are we alone? We still don't know. K218b has not given us the answer, but it has given us something almost as valuable, a reason to look harder, to ask better questions, and to dream bigger. Maybe we are the only thinking beings in this vast expanse. Or maybe we are just one voice in a cosmic choir we haven't yet learned to hear, but the search continues. The universe keeps inviting us to look deeper, to be curious, and to wonder. And sometimes, the most powerful discovery isn't the final answer, it's the question that starts the journey. This is how the universe communicates. Is Earth an exception? The search does not end with one planet, or one telescope. In the darkness between stars, in worlds without names. If life exists out there, if you're as fascinated by these cosmic mysteries as I am, be sure to subscribe for more journeys into the unknown. In the next episode, we will talk about the ghost effect in quantum physics, which connects particles faster than light, something that Albert Einstein himself called spooky action at a distance separated by light years, yet communicating instantly, faster than the speed of light. It sounds like science fiction, but it's a real phenomenon called quantum entanglement. Einstein strongly disliked the idea of entanglement because it seemed to violate the speed of light limit, a cornerstone of his theory of relativity. He believed there must be some hidden variable, a piece of information we didn't yet know, that would explain this apparent connection. Bohr, on the other hand, argued that the strangeness of quantum mechanics was reality. Who was right? The answer to this historical debate came decades later, with the work of physicist John Bell. In 1964, he proposed a mathematical test, now known as Bell's theorem or Bell's inequality. This test allowed scientists to finally verify experimentally whether Einstein's hidden variables existed or whether Bohr's vision was correct. Let's analyze the results of crucial tests, such as those by Ailing Aspect in the 1980s and, more recently, those by Anton Zeilinger, which earned him the Nobel Prize in Physics in 2022. The results were surprising and repeatedly confirmed that spooky action is real. Quantum entanglement is not just a laboratory curiosity, it's the foundation for revolutionary technologies that are already under development. Let's talk about quantum computing. Another incredible application is quantum cryptography. Imagine creating a 100% secure communication system, impossible to hack. With entanglement, any attempt to eavesdrop on a message would be immediately detected because it would alter the state of the quantum system. Have you heard of quantum teleportation? Don't worry, we're not talking about teleporting people like in Star Trek ... not yet. But it is already possible to teleport the state of a particle. That is, its information, from one place to another, instantly, using entanglement. But doesn't this faster-than-light connection violate Einstein's theory of relativity? That's an excellent and fundamental question. Let's clarify this paradox. Although the connection is instantaneous, quantum entanglement does not allow useful information, such as a message, to be sent faster than the speed of light. Let's explain why and how causality, the principle that cause precedes effect, is preserved. Finally, let's look to the future. What else can we expect from quantum entanglement? What are the next challenges for scientists? Are we on the verge of a new technological revolution driven by quantum physics? Let's discuss the boundaries of current research and dream a little about the possibilities that this incredible phenomenon holds for us. From quantum internet networks to ultra-precise sensors, the future promises to be quantum. If you've ever felt inexplicably connected to someone, perhaps the universe is simply following its own mysterious rules.